Tonight's video is a continuation of the study we began in class on sampling design, and we're going to go through the types of sampling designs and the advantages and disadvantages of each type as well. Our first type is a simple random sample, and most often you will see it abbreviated as SRS, as you see in the parentheses here. And this type of sample is very common in statistics, and it consists of n individuals from the population chosen so that every individual has an equal chance of being selected, and that every set of individuals has an equal chance of being selected. So you may want to pause the video at this time so that you can write down this information from the slide. So the first criteria for the simple random sample is that every individual has to have an equal chance of being selected. So let's say that we were taking a simple random sample of 100 Caney Creek High School students, and we put every student's name in a hat, and they were all on equal pieces of paper and folded the same way and so forth. And then we randomly selected 100 names from the hat, and so each student had an equal chance of being selected from that hat. Again, you may want to pause the video to write down any necessary information. The second criteria for a simple random sample is that every set of individuals chosen has to have an equal chance of being selected. So what that means is that not only does each student have to have the same chance to be selected, but every possible group of 100 students has to have the same chance. So therefore, it has to be possible for all 100 students selected to be seniors in order for it to be a simple random sample. Now, is it likely that all 100 we will choose will be seniors that we choose? No, it's not highly likely, but they still have the opportunity or the chance to be that. Stratified random sample is our next type, and this is when the population is divided into homogeneous groups called strata. And once we have those in the homogeneous groups, we take the simple random sample from the strata. And homogeneous just means that something is alike based on a characteristic. So each member of our strata would have the same characteristic. So say, for instance, I wanted each member of my group to have brown hair or something like that. So taking from our school example again, suppose we're going to take a stratified random sample this time of the 100 students. Now, since these students are already divided into categories based on grade level, then the grade level could be our strata. And so since we have them divided into these strata, the randomly selected 50 seniors and randomly select 50 juniors to give us our total of 100 randomly selected CCHS students, or you could take 25 from each grade level to reach your 100. Remember to pause the video when necessary so that you can write down everything that you need in your notes. Moving on to our next example is the systematic random sample. And we select that sample by following a systematic approach. And then we randomly select where we will begin. So, for example, with this type, if we wanted to do a systematic random sample of Caney Creek students, we would number the list of students. And since there are approximately 2,000 students in our school, we would take that number and divide by 100, which is the sample size that we were requiring. And that gives us 20. So what we'll do is select a number between 1 and 20 at random, and that student will be the first student chosen. Then we choose every 20th student after that, and that will be the sample that we use. Our next type is the cluster sample. It's based upon a location, and you randomly pick a location and then sample everything from that location. So again, for example, if I want to do that in our school, one way I could do it would be to randomly select 10 classrooms during second period. And within those 10 classrooms, I have to sample every student in the room. A multistage sample is exactly what it sounds like. You select successively smaller groups within the population in stages. And then the simple random sample is used at each stage. So for example, remember to pause if you need to write things down. To use a multi-stage approach when we're sampling students at Caney Creek, we could first divide the second period class by level, AP, pre-AP, regular, dual credit, etc., and then randomly select 4 second period classes from each group of those. Then we could randomly select 5 students from each of those classes, and so thus the selection process is done in stages. All right, next we're just going to look at some lists of advantages and disadvantages for each type of sample that we've talked about. The first is the simple random sample. Its advantages are that it's unbiased and that it's easy to do. However, sometimes you have a large variance, and your sample, if you're not careful, will not be representative of your population. And if your sample is not representative of your population, then it's no good, because it doesn't tell you anything about the population, which is why we sample things in the first place, to find out things about the entire population. And you also have to have a sampling frame to do this, which is, remember, just a list of those things in the population. Our next sample that we talked about was the stratified random sample. And it's good if we want a more precise, unbiased estimator than the simple random sample is for us. It provides less variability. And remember, variability is how far the data ranges. And it doesn't cost as much if the strata are already there for us. If our population is already divided into groups that are easily seen, like we had with our school example. A school population is already divided by grade level, which is easy to do a stratified sample with. A disadvantage, though, is if your stratum are not already there for you, then it's difficult to divide those into categories at times. And then when we have to use formulas for standard deviation and confidence intervals, which we'll talk about later, those can be more complicated. And you also need a sampling frame, which sometimes, remember, a sampling frame is nearly impossible to get. Now, if we're talking about a list of people in a school, sampling frames are easy to get because schools have already lists of people in the school. Next is a systematic random sample. It's good because it's unbiased. It's good because it ensures a sample across the population distributed evenly based on your calculations and where you select each sample. And it is more cost efficient. Disadvantages are, again, there's a large variance. It can be confounded by a trend or a cycle, depending on the way you had to systematically choose. And again, the formulas can be complicated. And lastly, the cluster sample. It's good because it's unbiased. It's good because the cost is not as much. And the sampling frame may not even be needed for this one, which is good if you have no way of getting a sampling frame. It's bad because a cluster may not represent the entire population, and the formulas, again, can be complicated when using. Our last design that we talked about was the multi-stage sample, but we're not going to discuss advantages and disadvantages at this time.